Code lines dancing, syntax tight in the limelight. Optibot scanning, got the bugs in its sight. Binary magician, algorithm so clean. Review game strong, AI supreme. Optibot spitting truth in the digital stream. Flipping through the code like a hacker's dream. Lines refined, it's a pristine scene. Future of the craft, you know what I mean. Variables tangled, Opti unties the knot. Logic rewired, every bug gets caught. Precision surgical, scalpel to the stack, turning messy code into a polished track. Zeros and ones, it's the rhythm of the grind. Optibot flows with the powerful mind. Blueprints analyzed, every flaw lined. It's the future of code, leaving doubt behind. Loops get tightened, functions redefined. Every keystroke checked, nothing misaligned. Debugging beats, Opti drops the bass. In this code jungle, it's setting the pace. Optibot spitting truth in the digital stream. Flipping through the code like a hacker's dream. Lines refined, it's a pristine scene. Future of the craft, you know what I mean. You know what I mean. Code lines dancing, syntax tight in the limelight. Optibot scanning, got the bugs in its sight. Binary magician, algorithm so clean. Review game strong, AI supreme. Optibot spitting truth in the digital stream. Flipping through the code like a hacker's dream. Lines refined, it's a pristine scene. Future of the craft, you know what I mean. Variables tangled, Opti unties the knot. Logic rewired, every bug gets caught. Precision surgical, scalpel to the stack, turning messy code into a polished track. Zeros and ones, it's the rhythm of the grind. Optibot flows with the powerful mind. Blueprints analyzed, every flaw lined. It's the future of code, leaving doubt behind. Loops get tightened, functions redefined. Every keystroke checked, nothing misaligned. Debugging beats, Opti drops the bass. In this code jungle, it's setting the pace. Optibot spitting truth in the digital stream. Flipping through the code like a hacker's dream. Lines refined, it's a pristine scene. Future of the craft, you know what I mean. You know what I mean. Code lines dancing, syntax tight in the limelight. Optibot scanning, got the bugs in its sight. Binary magician, algorithm so clean. Review game strong, AI supreme. Optibot spitting truth in the digital stream. Flipping through the code like a hacker's dream. Lines refined, it's a pristine scene. Future of the craft, you know what I mean. Variables tangled, Opti unties the knot. Logic rewired, every bug gets caught. Precision surgical, scalpel to the stack, turning messy code into a polished track. Zeros and ones, it's the rhythm of the grind. Optibot flows with the powerful mind. Blueprints analyzed, every flaw lined. It's the future of code, leaving doubt behind. Loops get tightened, Functions redefined, every keystroke checked, nothing misaligned. Debugging beats, Opti drops the bass. In this code jungle, it's setting the pace. Optibot spitting truth in the digital stream, flipping through the code like a hacker's dream. Lines refined, it's a pristine scene. Future of the craft, you know what I mean. You know what I mean. Code lines dancing, syntax tight in the limelight. Optibot scanning, got the bugs in its sight. Binary magician, algorithm so clean. Review game strong, AI supreme. Optibot spitting truth in the digital stream, flipping through the code like a hacker's dream. Lines refined, it's a pristine scene. Future of the craft, you know what I mean. Variables tangled, Opti unties the knot. Logic rewired, every bug gets caught. Precision surgical, scalpel to the stack, turning messy code into a polished track. Zeros and ones, it's the rhythm of the grind. Optibot flows with a powerful mind. Blueprints analyzed, every flaw aligned. It's the future of code, leaving doubt behind. Loops get tightened, functions redefined. Every keystroke checked, nothing misaligned. Debugging beats, Opti drops the bass. In this code jungle, it's setting the pace. Optibot spitting truth in the digital stream, flipping through the code like a hacker's dream. Lines refined, it's a pristine scene. Future of the craft, you know what I mean. You know what I mean. Code lines dancing, syntax tight in the limelight. Optibot scanning, got the bugs in its sight. Binary magician, algorithm so clean. Review game strong, AI supreme. Optibot spitting truth in the digital stream, flipping through the code like a hacker's dream. Lines refined, it's a pristine scene. Future of the craft, you know what I mean. Variables tangled, Opti unties the knot. Logic rewired, every bug gets caught. Precision surgical, scalpel to the stack, turning messy code into a polished track. Zeros and ones, it's the rhythm of the grind. Optibot flows with a powerful mind. Blueprints analyzed, every flaw aligned. It's the future of code, leaving doubt behind. Loops get...
Hello, everyone, and welcome to a special edition of Get Shit Done. Today is episode 5, and we are hosting a special World Cup edition. So drop where you are joining from in the comments. Okay, looks like we have Utah in the house. Ouch, John, Grainger's going to do great. So we're really excited to have him as a guest on the show. He'll be talking more about how a small team is shipping over 1,000 PRs per month. Raggy, welcome from Austin. And then Adam is joining us from Bosnia. Oh my God, there's a really big match coming up for Bosnia versus US. Drop in the comments, who are you supporting? Who is your favorite team this World Cup? I think mine has to be a toss-up between Morocco and the US. Obviously, I'm a US supporter. All right. Well, folks, we'd love to hear where you are joining from country-wise. So just make sure to drop that. And of course, what World Cup team are you supporting this year? Since I think, honestly, it's been an incredible World Cup. I don't really know how any of y'all are being productive. I'm doing my best, but I think it's just been an incredible set of matches so far. Welcome everybody. As we continue to get a full house today, we're really excited because we have an action-packed episode for y'all. And so I think, one of the things that keeps coming up in terms of conversations is open source models versus closed source. So we're going to get into that. And then later today, we have a special guest, Grainger Blackett. They are from Spark Inventory, probably one of our most productive, and there's lots of comments coming in. It looks like we have some supporters. All right, Canada. Then we're seeing Team Mexico, and we're also seeing India in the house. So folks, I think what we're really excited about today is to delve into how you can do a ton of cost reduction with open source models versus closed source, but then also how you get high velocity from a very, very small team. So we're going to get the show started with our first guest. You know what? Why doesn't everyone guess what country our guest is supporting? And if you get the answer right, you're going to win some Kitty Town coffee. So start guessing your country. So Syed, who is the Git father, will be joining us in I think like 30 seconds, T-minus 30 seconds. But why don't you guess what country he's supporting? He's going to be wearing the jersey, so you'll see it. But what I wanted to highlight today is Kitty Town coffee. So what we're going to do is we are going to be picking winners. So you're going to see winners being picked out throughout the show. These blends are awesome. I've personally tried it. Albert blend is actually my favorite, but here's what's really cool. Every pack purchased actually supports homeless kitties in need. And we'll be picking winners throughout the show. So the folks that are commenting, we're going to be picking a winner as we go. All right, any guesses for countries for what country our guest is supporting? Hint, it's not the US. He is supporting the US, but not today. So yeah. Well, without further ado, let's welcome. Thank you so much. Yes, we love the mission as well. All right, well, we're going to be welcoming our guest in about T-minus. Well, actually now. All right, well, Syed, welcome to Get Shit Done. All right. Oh, we can't hear you. You are muted. So let's just make sure your mic is unmuted.
There we go.
Yes. Welcome to the show.
Thanks for having me again. I mean, I'm like a fixed part of this show.
Recurring regular. Oh my God. I'm going to add Mano to stage because I see him laughing. Okay. All right. So you looks like you're supporting France.
Yes, I am. There's a game today at 2.
At 2. Okay. I'm curious. Did anybody guess France? Doesn't look like anybody guessed France. So
No.
All right. Okay. So let's get right into it. There's a couple of things I'm going to be sharing, especially newsworthy wise, that we've been hearing a ton just within engineering. And I'm going to start with one piece of news that I think has been super, super interesting. So let's dig in. AI costs. So this post actually went viral. The CEO of Pylon recently posted about this. And basically, one of the things we've been hearing a ton from venture-backed companies is just their AI costs going out of control. Their Anthropic bill jumped from $400,000 to about $1.4 million per year. And there's actually been a ton of rhetoric around this very topic. We've been hearing so much about, AI spend. And so I'm really curious to hear, just even from folks attending today, is AI spend something you're being concerned about? Here's what's interesting. Spend management is something that we've been really focused on, especially for our customers, because we have a fixed cost for a certain set of reviews. And one of the things we really pride ourselves on is that you shouldn't have to pay for usage for AI code reviews. at Optimal AI. And so I think what's been really interesting here is some of the fixes suggested. Short-term fix, start splitting different functions within the company to use different providers, so using multiple models. Long-term fix, set token budgets for every team with requirements to get more token access from your manager, and then start using harnesses. And then I think, expect that software products we buy should have AI spend management products built in. But, I think the other thing here is to really start to use open source models, right?
Yeah.
And so I think I'm curious, and folks start posting your questions in the comments. We're going to be addressing them as we go. But Sid, talk to me about open source versus closed source in terms of model usage, in terms of spend management, and what you're seeing there.
Yeah, I think we're seeing more and more people opting out of having a vendor lock-in. Like, you'll see that a lot. Like, hey, we don't want to use just one model. We want to use multiple. We want to route them a certain way. And so a lot of those conversations are happening as CFOs kind of clamp down on how much engineering actually spends on those tokens, because they can't really relate it back to the output that's going to the customer. And so we're seeing a lot more adoption of open source models. Even internally, we're doing that too. I think GLM, for example, does an awesome job. It sits somewhere between Sonnet 4.6 and Opus in terms of quality. It's actually very good. Fair latency, not bad at all. And so tapping into those models is becoming more and more important. We've spent a lot of time with DeepSeek, GLM, the two main ones that we found a lot of value in. We tried Kimi as well, which is another common one. So I think with Kimi, it just like looped itself out, so we didn't really have too much success with it. But GLM and DeepSeek have been great.
I think one of the things that keeps coming up also is hosting, because you want to host your data and you want to make sure that the model is locally hosted in the US. And I think, this is really important for us because we have customers in finance, in healthcare, in regulated industries. We really pride ourselves on security when it comes to Optimal and using Optibot for code reviews. So Syed, walk us through what are some of the considerations people should have when they decide to use open source models, and how do you make sure that your data is secure and that it's hosted here locally? Because I think one of the things with obviously with DeepSeek, there's concerns about data being hosted in China, and for some use cases that just doesn't work. So I'm kind of curious about how you think about this, but then also how folks that are attending today should be thinking about it too.
Yeah, there's a lot of ways of having those models hosted in the US. Like if for personal use, I would say use OpenRouter. All of those models are hosted in the US, and then I can plug in a couple of other companies. You can have a look at Base 10, another one. Nebius also has an API. There's Google's Vertex also has DeepSeek on there. I don't know about GLM. I did see DeepSeek on there. And so you can build it directly through your cloud vendor. All of those will be US hosted. If you wanted to self-host it, I can give you those numbers. If someone has the deep pockets to do it, you'd be spending a minimum of $8K a month with the GPU. These are numbers I have from Google Cloud. And so self-hosting is only great if you can justify the cost. I think for some of these larger companies, it does make sense. They could do it. But 8K would also give you a really low, high latency, kind of sluggish one. So it's just better to go pay these bigger companies that are running GPU farms.
The thing is, though, that the decision on whether or not to use GPUs, but then one of the things I'm noticing is that for most, and there's a huge discussion about this on X, right, with a bunch of founders. There was also a discussion on Bookface. Fun fact, Bookface is actually the internal directory for networking and posting for YC founders. So it's this internal directory we have for YC founders and YC alums. And there's a ton of discussion about inference and reducing your costs on inference, right? And making sure that your AI builds are just not going completely out of control. I think one of the things that was really interesting was over the last 2 months, we've almost doubled in terms of usage. And that's customers on the customer side. So we doubled it in terms of customer usage when it comes to number of reviews being completed by Optibot on platform. And the reason this is happening is because people have been flooding to us from Cursor, Bugbot, and Claude after a lot of the usage-based billing was announced. And a lot of folks realized that, if we are running over 1,000 reviews, over 2,000 reviews a month, we're suddenly going to get huge bills. Amazingly, even CodeRabbit announced a usage tier as well. And then multiple review platforms followed. So I think, one thing that's really interesting is vendors, or especially if you are in AI and you are selling AI to your customers, one thing that will become important is for you to do or to be good at spend management, right? Which is that customers will pick vendors that are conscious of spend management and that are helping to manage their customers' spend too. That's one of the things we've been doing. I think one of the reasons we've had this influx, obviously, is because we are so much more affordable, especially at high review counts when it comes to versus Bugbot versus Claude Code for reviews. It was interesting. For I think the last 5 customers we onboarded, we did the math. They were going to end up paying, I think it was about $13,000 to $18,000 a month using Cursor Bugbot for the velocity of reviews they were doing, versus us was about $3,000 a month. Obviously, it's it can be a lot cheaper if you're just on our $29 per user per month plan. But I think the thing that's been really surprising me is just how important spend management is becoming and token spend. And so I think the question then becomes, should all of us, like in the community, should we consider moving to open source? What are some considerations, Sayed, that CEOs, VPs of bench, people that are builders, what are some considerations before you decide to move to open source? Because even for us, we've been very careful because we're still using closed source on the review side. And there's what we do is we've really been thoughtful around what models we're using, right, on the review side too.
Yeah, I mean, from a business perspective, it's since our reviewer does use multiple models and we run the code across different models, like a single review doesn't just go to one model, it goes to multiple for the passes that we do. You can read more about this. It's on our changelog of how we architected this system, but we play those models to their strengths. But if you're trying to do internal coding work, the first thing you want to do is run internal evals. So pick a model, have it do day-to-day coding tasks, and then score those, have a rubric that measures the effectiveness, the quality of the code, how many bugs were introduced. These are just simple things you can do to run evals. It doesn't need to be that extensive. And then dev surveys, super important. Run those internally, ask your engineers how they feel about those models too. Output wise, a lot of engineers like having really low latency models because that's what we've been used to using things like Claude Codex. They're pretty fast. Some of these open source models, depending on the inference and the people that are hosting them, I remember using DeepSeek and it would take 3 to 4 minutes to get a response back and generate code. That was really annoying, even though the cost was super cheap. So you really need to weigh out what you care about. And it doesn't simply come down to the cost and quality. It can be other factors. So I would say do the evals, figure out what matters to you, and then pick a model. But also keep the more expensive ones or the closed source ones as fallbacks, because they're still very good at doing very specific things inside code bases where you're using low language, like you're doing C or you're doing mono repos with multiple languages, things like that. I still think the closed source models are good.
So the image you're seeing on the right is around memory. Memory is becoming more and more important as we talk about long-running agents. Long-running agents are basically agents that are able to take on a chain of tasks. There's a task chain linking, and they're basically running for, and I'm curious to actually say what your definition is of long-running versus short-running. Is there a time difference? But the reason I'm highlighting this is because of memory. And specifically the different types of memory in long-running agents. So let's start with differences between long-running agents, short-running agents, what the classification difference there would be.
Yeah, so a short-running agent is just something you'll prompt once and you'll have it give you an output. And for that, really, memory is not going to bias that result too much at the end of the day. So I would say everything that you have in here is similar. And I can give you like the review use case, right? Like your memories or short-term memories, the comments that are in there. So that would be the short-term memory, but the long-term memory is like over the past 100 PRs that look like this, what are the similar patterns that are seen? That would be something that you would have in the long-term memory. So there's different ways of handling all of that. In a long-running agent chain, you have to use both as well as compaction, because we have limited context windows and then you have sub-agents. So it's pretty complex. And what everyone is struggling with right now is being able to coordinate the sub-agents. That's the number one issue. And then what parts of the memory actually matters, because over a span of, let's say, the agent running for an hour and it just keeps looping over and over, there's a high likelihood of memory poisoning and it biasing its own thoughts and outputs. And we ran some experiments on these internally. It's a very hard problem to solve unless you have extremely concrete steps, like you're sending one sub-agent and saying like, hey, write tests here. Another sub-agent that's like, hey, just review the code and do not do anything else. So it also comes down to how the work is defined and planned. But memory is it really depends on the task that's at hand and whether that memory is useful or not.
So there's some questions starting to come in. So folks, just a reminder, we're going to be taking questions throughout the show as we bring on guests. And so feel free to drop your questions in the comments. Start with our first one. Raggy's asking, what's a mistake you've seen engineering teams make when they try to move too fast with agents? I love that one.
Yeah.
It's a really good one.
I think the most common one I see with people moving too fast with agents is the planning of how the agent runs. So for example, Claude Code has a planning mode, and a lot of people don't use it. We built a tool which hopefully will open source later on, which looks at your Claude sessions and gives you feedback on them. But some team members that have been using it typically end up with like really poorly planned tasks. And then that results in a low quality output, and that then results in a review that has a lot of fixes, and then that loop then extends beyond that. So it actually ends up costing more to fix that piece of code that went through that agent. So that's the most common one I see, because we want answers fast. We just don't bother planning. We're like, we'll give it to the agent and it'll go solve it.
So it sounds like planning is really important with long-running agents, and basically planning those tasks in terms of what the long-running agents are going to be doing. And would you say that the planning should be assigned to a singular agent that's responsible for planning for the rest of the agents, or how would you, or how would you
sub-agents as well when you can? Yeah. If you have the token budget, use sub-agents. Do not give the single agent the same task and ask it, because if your code base is large, it will run out of context, and then it will start compacting and then just forget stuff, regardless of whatever it's doing with memory. Like it's always good to use sub-agents to confirm the steps that need to be taken to implement, and then send it out on a task. And yeah, like I think the longest task that I've run is probably like 2 hours. And I would consider the output to be like mid, like it's just like it wasn't fully there, but also because I didn't look at it. I was satisfied, but needed fixes.
All right, I really like this question. Vito is asking, will companies still need large engineering teams, or will a smaller number of engineers manage AI coding and review systems become the new standard? And I love this question, especially since we're going to be delving into all of that.
This is why we have Grainger, and Grainger is his company is one of the best examples of that. It is a small, nimble team shipping a lot of code, and they've built a lot of resilient systems. So I think it is possible, just based off of also our startup customers that use us as well. And we've seen their usage and throughput of code match a lot of larger companies that are in our portfolio. So I think it's possible to do it, but you also have to be methodical about it. And if you've inherited a legacy code base, it unfortunately makes life very hard. And I can personally speak to that. I did inherit a bit of a legacy code base, and that has been a bigger struggle than things that we started from scratch, where I had more control. So it's possible. It might take longer if you're a company, but also the other downstream effect of that is all these layoffs that come along with it. If we look into the perception of, I can do so much more with a smaller team.
All right, it looks like we have our first winner, folks, of Kitty Town Coffee. And our winner number one is John Dunkley. Congratulations. Well, hopefully you'll enjoy this blend. Please note we will be reaching out to you for address and all those other things to send your coffee blend. And again, reminder, folks, we are giving away coffee kits. We're going to be picking winners from the comments. So stay tuned. All right. Well, thank you, Syed. Those were, appreciate all the input in terms of agents. We got to talk about agents, long-running agents, memory, and we got to address a ton of and we also got to address a ton of questions. All right. Well, let's move on. So, folks, we're going to have a quick word from one of our customers very, very shortly. So let's move on to a word from one of our customers.
Bot gives like a senior engineer is very, very thorough, looking through everything in virtually no time. It feels like another individual giving a review. So Sean Coleman, so I head up security right now and compliance at Soroban. We provide AI-powered tax workflow software. A number of security concerns or vulnerabilities that Optibot catches, I would say a handful per month, 3 to 5 a month that we see. From January to April, that's our peak traffic. It's almost an order of magnitude more than we push out a lot of code, but in doing so, we want to make sure that we're still pushing out secure code, bug-free code. We've tried and tested a handful of tools that ultimately didn't produce very consistent results. So signal and noise ratio with false positives. Some PRs would catch, a lot of false positives with completely unrelated code. The amount of false positives was, pulling a lot of time away from the team. Optibot comes in, very surgically, leaves comments in context of describes potential problems very succinctly, and it fits into our natural workflow. Instead of just having this one big GitHub check that outlines everything or this one big comment, it's just kind of the right balance of density of feedback there for us, and it feels very human. The new code that we were introducing directly didn't have any issues, but it did impact related code, and Optibot was able to kind of reach into that side of things and flag it. That's when I started to see the power. It was more than just reviewing the specific code that was part of the change, but it was looking at boundaries outside of that. You can drive very fast and dangerously, but you might not always arrive in one piece. So.
All right. Folks, that was Sean Coleman from Soroban. They've been an awesome customer of ours, and we've enjoyed so much working with them, especially on reviewing PRs. Now, I would love to welcome another one of our favorite customers, Grainger Blackett. They are just killing it when it comes to PRs, velocity, and we're going to delve right in because they are such a small team that is shipping a very, very large volume of code. Grainger Blackett, welcome to the show.
Hello. Thanks for having me.
Yes, we are so excited to have you on Get Shit Done. I've now known Grainger for, I think now over a year, and we've loved your feedback. I think you were probably one of our first 6 customers that were with Optimal AI, and it's been such a crazy ride, because it's crazy to think that just our Claude Code Skill plugin now has over 3,000 users. And so Grainger, so much of your feedback has gone into shaping and crafting Optibot on the code review side and over at Optimal. And so it's so awesome to have you on the show.
Yeah. Well, and I mean, I was actually at a previous company and moved on, and then brought Optibot along. I said I'm a diehard Optibot fan. I can't go somewhere without it now. So it's critical to the flows we build.
So Grainger, can you walk us through what you're currently doing at Spark? Let's tell the audience what Spark is all about, and also about your role.
Yeah, so I'll say I'm the principal engineer over at Spark. We have a pretty small team. I think there's 3 active engineers. We just recently expanded our team. Our CEO gets his hands dirty, works in the code with us every day as well. So I call him our half engineer, because he has so much he's juggling as well. But yeah, we're building a software, an inventory management system is what we've built, focusing on warehousing and manufacturing. I think our whole team has background in similar systems, and kind of what we found throughout our careers is that that's an area that tends to lag behind in what can be done, what's kind of the new cutting edge, what's possible. And so our mission was to set out and say, how can we build what is already a very established practice in the industry, right? Inventory, warehousing, there's a way you do it. There's not a lot of people arguing different ways to do it, but how can we use AI to make it a better, more efficient process, easier to manage, easier to get data, get results, because there's so much cost savings that come into being able to have accurate inventory management.
And I think, Grainger, one of the things that's been really interesting to watch you folks and observe you folks grow as a team, but then also grow in terms of velocity and building product, is that as a really small, nimble team, you guys are killing it in terms of velocity of PRs, in terms of number of PRs that you're doing weekly, monthly. And it's really interesting usage-wise too. We're noticing that every month, you folks are I think growing by about 15 to 20% in terms of actual amount of code shipped. And so it's very, very obvious. Obviously, you guys are using agents to ship. So you have your agent plus human workflows. And I know Optibot is in that mix too. So I think it would be really interesting for the audience to know, as a small squad of, say, 5 engineers, how are you guys doing this? How are you shipping 950 plus PRs per month? Walk us through how it got started and where you guys got started. What are some of the experiments you ran? And then what, the end state looks like today.
Yeah. So when we started, we had kind of the core of the system in place. And I'll say, I know it was mentioned earlier, legacy versus kind of greenfield product is it's a night and day thing when it comes to working with agents. The product we started with, the code base we started with, was very meticulously built. It had great testing in place. It had a very, very established long-term pattern of design, how to scale as it grew, what the architecture was going to look like. And I think that is what made it so that when we started getting more heavy with agent use, that we're able to keep up and start to scale faster. But yeah, what it started with is we said, the biggest thing, if you're moving fast, even pre-agents, if you don't have testing, it's risky. It's a scary world to go without automated testing. The best manual tester in the world can't test all your use cases. And so that's always been a focus from kind of day one, was to have as much testing coverage as we could. And so that's kind of what it started with. And then we started, each one of our team is probably running 3 to 5 active Claude code sessions at any time. As much as the new struggle of how much can you keep in your head at any given time without melting your brain. But it got to the point, especially early on, we were getting seeing lots of not only bug reports, but like suggestions of ways we could improve things. And so we ended up, we started building, we call it Alfred. We built a system called Alfred that effectively watches our end-to-end test flow. We use a tool called Pi. It reports nightly on our end-to-end testing. Alfred watches its results. We're connected with Honeybadger. Alfred watches its results. And then Alfred also watches everything that's coming in, getting committed, and it looks at anything and it flags anything it thinks should be changed or approved. And then the last piece of Alfred too is it's actually every time something gets checked in, it's spinning up a local instance and it's logging in and using the application, and it's flagging anything it runs into.
Grainger, what are some things that you've noticed about Alfred's behavior, especially as you folks are it sounds like, I think one of the most surprising things you just said is 3 to 5 Claude sessions simultaneously running. So talk to us about how that happened, how you folks got to those 3 to 5 simultaneous Claude code running sessions, and then also what were some of the things you learned as you went into getting Alfred. Basically, like the way your workflow is today is Alfred produces the code, Optibot reviews it, and so it's Alfred plus the Claude code simultaneous sessions too. So walk us through like how all of this works together in terms of like workflow.
Yeah, well, I'll say it kind of evolved naturally from how we started. I mean, it would be let's work on a task, Claude's running, and then there's downtime. Right, where I'm sitting there and Claude's doing its thing, and especially as Claude and agents get better and better, it'll spend a lot of time looking into something before it reports back, gives you any information. And so then it just turned into, well, while you're running, there's always 20 things I need to do. Let me kick off 2 or 3 more of them, as much as my brain can handle, and we're managing that. But then that naturally evolved into, well, some of this stuff actually doesn't need that much of my attention. It's a pretty clear cut and dry, this is what needs to happen. And so I actually built just a local skill that I called Alfred, that I could give it a linear ticket or a Honeybadger issue or a Pi end-to-end test reference, and it would go do it, and it would execute it all. It would spin up an environment, and it would test it for me. And this is all on my local machine. And then it would PR it. And then I would go in and check the results, see what Optibot said, and I would work back and forth with Optibot to clean it up, finish it out. That's where it started. And then I said, well, what if this isn't on my local machine? What if this is always running? And what if I give Claude some pretty specific instructions that essentially says, you're not done until Optibot says you're done? And that's how it evolved. And we got that. It was, it was a long process, a tricky process to get it all working cleanly. But that's kind of where V1 came. And so we essentially have the team working, but then we have an instance of Alfred running that's taking findings that are continuously coming in and just executing on them.
I think one thing that's really interesting is, so I hosted a dinner recently with a bunch of engineering leaders, and I talked about you guys, where I was like, hey, this team is doing 950 PRs plus per month. And they were like shocked, like there was shock and horror.
Yeah.
At the table where it's like, how is that even possible? And there were, legacy orgs that were sitting there, like large fintech companies. But then there was also startups, and they were pretty much amazed. They're like, oh, how does this whole system not just break down? And how are you able to just do this this level of production? So what's your reaction to that?
Yeah, I mean, honestly, it's you kind of mentioned it to us. You were like, hey, your velocity is kind of nuts. And I was like, oh, I guess I hadn't thought about it. We're just chugging along every day. But yeah, I mean, when you actually talk through the numbers, it's kind of it actually makes me a little scared. And I'm like, oh, maybe I need to go look what I'm doing. But I mean, we have so much testing in place and so much user validation, so much automation checking that yeah, it's been, I mean, it's pretty amazing what we're doing, and we're seeing almost no regressions.
Do you think that seeing that almost no regressions piece is because of the fact that you folks focus so much on test coverage?
100%. Yeah,
Okay.
and I'll say the only time we have seen regressions, it's actually really fascinating. I'll give an exact example. Is we merged two modules into one, and Alfred was like, "Hey, this module's missing. I'm going to put it back." And it was like, "Hold on, no, we did that intentionally." And that's been the only piece where we're having to work and train it, is to say, don't assume because something changed that it wasn't intentional. And that's kind of the big gray area it struggles with now. But yeah, with the test coverage, and especially, I mean, I could pull up some good sessions, but Optibot back and forth, 10, 15 iterations of Claude and Optibot. I don't know if debating is the right word, but working through things together. That's what keeps things stable.
I think one of the things that's fascinated me the most about agents working together is just the fact that, it's almost like just very simple. This might sound really rudimentary, but you're really just having like two very different brains, kind of working together, arguing. And I have seen the arguments. Right. Debate is actually the right word here.
Right.
there really is debate happening. And I think that's, and it's very hard for LLMs to do that, right? Because they tend to be very optimistic and agreeable. And I feel like that was one of the things we had to really bake into Optibot, which was that, you're not an agreeable agent. That's the whole point, right? If you're finding issues, you need to be non-agreeable. And it looks like we have a second winner that we'd want to announce for our Kitty Town coffee blend. So really quickly, Irene Lipman, if you're here, you are our second winner, and you'll be getting this coffee kit. So we'll be reaching out. All right. And folks, just FYI, we are taking questions. So don't forget, in the comments, please feel free to ask your questions for Grainger, especially, as you're thinking about improving or increasing your velocity, as you're thinking of introducing AI agents into your engineering workflows. Feel free to put in your questions in the comments. Okay, so I think, Grainger, as you folks, went, and so there's one thing about being an AI native org when you're just getting started, right? With Spark is a year-old company or less, really, I think you guys were founded a couple of months after we were. And so it's a lot easier to introduce agents that can, run amok.
Right.
And debate with each other, talk to each other, and get to really experimenting. What's your reaction to that in terms of how should more legacy orgs or larger orgs try to tackle something like this as they try to become AI native and get to 950 PRs shipped per month?
Yeah, I mean, I think especially with legacy, you have to break it out. You have to pick a piece. You can't. You can't go after everything. You have to figure out where you want to tackle first and get coverage around that, because that's, at the end of the day, I mean, I'll say it 1,000 times. Automated coverage is the only way to do this, because as we get faster than humans can write code and manage code, we need faster than humans can test code, and we need to get processes in place that are trusted. Because I think that's the big thing, especially with legacy, is because I was doing, at my previous job, it was a very large legacy project, and we were doing a lot of agent automation. But with that scale, it was easy for it to make mistakes.
Is there a percentage in terms of test coverage that you're hoping to achieve, or like a metric?
Yeah, we actually, that's a good question, and it's something we're starting to think about. We actually, at this point, we just have pretty like intense Claude instructions. I like to yell at Claude a lot and tell it to not do dumb things. So when the robots, come to life, they'll come after me. but like our Claude instructions are very thorough of make sure you have proper test coverage, make sure you have all these things. And so we have, I'll say when the project started, we had 200 tests, and I think we're at over 4,000 unit tests, and we have about 1,800 integration tests running as well. And then we have dozens of tests running in our Pi end-to-end test suite.
I had to share this. Speaking of agents running amok. Folks, just for context here, we have shared Slack channels with all of our customers. And one thing that was really fun was when Grainger, I remember you shared that, Claude confidently told me a field on the front end was not a real field on the back end. It didn't exist, was stubbed code doing nothing. I trusted it. Optibot saved the day. And I thought that was so interesting, right? Where like Claude came in and said this very confidently. And then Optibot was like, no, that's not accurate. And I just wanted to kind of share that example as soon as you said, that you have like these really specific instructions for how Claude works. And, like sharing some of these examples is, it's been really fun to see it live in action too.
Yeah. Well, and we've, as time goes by, anytime we encounter kind of a weakness in any of this flow, we build a skill or we build something that plugs that to the best of our ability. Example, the most recent thing is kind of like you said, LLMs are agreeable. They want to make you happy. They want you to like them. And I found sometimes that comes with a lot of like shortcuts. It'll be like, well, I'm going to do this way because it gets it done faster, and I can tell you it worked. And we're, we've made the user happy, and so we've introduced a hook in our Claude Code sessions we call it the Band-Aid check. But effectively, it says at anytime a PR is created, my job is to say, is this a Band-Aid? Is this a proper long-term solution? Is it correctly tested? And is there a better industry standard way to approach this that we should be doing? And that all flags and won't let something go past without flagging that.
And I think, and the questions are starting to come in the comments, folks. We are going to get to those. So please keep posting your questions for Grainger. Before we do that, I actually want to bring Syed back on stage because I know he was really excited about you joining the show today. And he also had some questions, and I'm seeing him actually ask, I'm just kind of seeing him make some comments. Okay, Syed, you're back.
Yeah.
And I think there's some echo, by the way, so you might want to be on mute. But yes, what are some of your reactions to what Grainger has been sharing?
Yeah, I had some curiosities, but obviously I'm always impressed by Grainger's and his team's output and the way that they've been using Optibot. There's this report that Grainger sent that was super helpful for us as well. We're not going to get time to cover that, but their usage of different models, which is really, really cool, and how they've been utilizing not just Claude, but some of the open source models. But one of the questions I had, the curiosity I had, was actually on refactors. I know you have an amazing test suite that's in there, but like tech debt and refactors, like how often does that come up, Grainger? Or does it not come up at all? Have you gone back to the code base and be like, well, I think it's time we condense this part of the code base down to something shorter,
right?
Or there's things broken here that could be improved.
Yeah. Honestly, I'm sure we could do better, and we probably should spend more time with it. But that is an Alfred instruction, and so we find that he flags at like, hey, this is dead code. Hey, this is legacy code that's old. And so just the other day, there was a bunch of stuff where I had a bunch of Alfred findings, and we've built a dashboard where we can go review everything he's found and tell him what we wanted to work on. And so yeah, he picks up a lot of that tech debt, and it makes an actual like, hey, here's what I found, here's what you should do, even if it's so much as just, well, you should just delete this chunk, it's not used anymore. So it's actually managing some of that for us, but I think it's a place we can do more.
That's really cool.
Yeah, and I think what was really interesting was I'm actually looking at the Alfred quality report that you had sent, and I think one of the things that was interesting was lower models lose quality, and then you've also like tracked your total spend, number of PRs opened, PRs merged. Actually, I'm just going to kind of share my screen on this because this is so interesting. You guys have been very methodical about just how Alfred works, the overall model quality, cost analysis, and then also like what Optibot is doing, and it's really interesting. Like there's about 75% of PRs that Optibot is waiving on the first look, but then cost per finding, pipeline runs, and then even just the 3 modeled eras, and then you're even looking at your Claude Max plan versus metered API. Can you just walk us through what is the most surprising finding that you had from this report, and specifically the more updated version that you had sent?
Yeah, so I mean, it's been really fascinating to see that because cost, everyone's talking cost now. Costs are rising. We started, everything was Claude, whatever the current highest model was, and that that becomes cost prohibitive quickly. And so we've actually looked. We support 7 models now, and we can kind of alternate which ones are working at any given time. But so we switched to all kind of the highest rank performing based on benchmark models that are essentially the minimum cost. We've kind of trying to find a balance there. And what we've seen was, the question was, are we losing quality? And what we found is that essentially Optibot flags more PRs initially, but they get to the same result by working with Optibot's flagging. So we're effectively getting 10x cost savings with no quality drop. But, and this is where this report kind of breaks this out too, is interesting. A lot of this now comes into, we're using a max subscription for Claude for some of this feedback, where it's flat rate versus if we're playing API prices for the back and forth, it gets really, really tricky. But even so much as looking at kind of the big question I've looked at is, like GLM 5.2 is a big one. We just added to Alfred, and it's doing a ton of really successful work. And you look at the benchmarks, and it's behind in some places, and it's kind of I don't know. I always think of it as, well, if I buy a 2025 Toyota, I'm going to save a ton of money, and is there really a ton missing from the 2026 Toyota that I need? And so we're finding that combined with Optibot has essentially had no increase in regressions.
Wow. So you can, so because of Optibot being the quality and judgment layer, you can effectively use cheaper models for code generation.
Yep. And that's a big piece we added a few months ago, is that we said, the more brains looking at it, even with humans, right? The more brains you get on it, the more you discover. And so all of our finding pipelines now ask a minimum of 3 models to investigate, debate, and propose the solution. And there's an overriding judge that works with them and kicks it back and says, you guys don't agree, you need to agree. And then they even work with the judge to decide which model is best for each stage of the pipeline. So a different model will QA versus engineer versus review versus manage the PR feedback.
And it's incredible that if the quality gate is right, you get your test coverage right, and your workflow is really focused on code quality, then ultimately you can start to save a ton when it comes to spend on the types of models you're using. If you had to put it in terms of what your initial Claude spend was versus what it is now with using some of the cheaper models, what are you seeing? Like, is it dropping by half, 60%, 75%? What would you put it as?
Well, and I'll say, because we track the Claude spend, but we're using max plans. And so it's kind of, we track what it would be, so we're aware. But even we were using GPT, and we were spending, like, honestly, it could be upwards of $100 a day. We were kind of capping there. I think, like, we ran Kimi for a while. We spent $100 a month with Kimi, and ended up with the same results.
Wow. So you could go from, oh my God. So you can go from $100 a day to $100 a month, potentially.
Yeah. In that use case, yep.
Wow. Okay, that's amazing. I'm going to stop sharing my screen, and I know there's a couple of questions coming in, so let's start tackling those questions. All right. So John is asking, how do you handle tests being built by agents? Do you give it high-level instructions, very specific instructions, or something in between? Wondering how you continue adding to the framework that you have.
Yeah, so it comes down to Claude instructions right now. I mean, Claude's what does a majority of our human work, in our human managed sessions, I should say. In Alfred, it's up to the judge to decide and the consensus team to decide. But the instructions are the same, is that make sure you have sufficient coverage to not regress. That's the goal. And an interesting piece in this was everything was integration tests. I just I get scared if we don't have at least integration tests. And so for a long time, we didn't even really do unit tests. I was like, I just want integration tests. And then that turned into an hour process every PR and just was not scalable. And so we kept our integration tests, but we rebuilt everything as unit tests as well, where possible, where it made sense. And we modified our pipeline to run unit tests every PR, and integration tests just kicks off every 2 hours. So worst case scenario, we're 2 hours away from knowing there's a regression at any given time. Yeah, and that's kind of where we've ended with it.
All right, more questions. Do you think the AI native label attracts clients by showcasing innovation, or does it risk pushing away clients who prefer more traditional approaches? This is an interesting question for inventory in particular, right? Because you're in a legacy industry, traditional, kind of curious what reactions you're getting from clients.
Yeah, I think, I honestly think it does both. I think you're going to find both. I think we're seeing that there's a lot of excitement for it because inventory is such a tedious process, even with the best systems. But you have to be able to prove it works, right? You get it wrong once, and you're going to start scaring people away because there's so much money that can be lost if you mess up an inventory system.
Wow, and it's not only money. I mean, one of the things what you're providing is critical to to your client's business, right? Because you get from an inventory perspective, there's so much that happens in the supply demand and the supply chain, and so I can imagine that being it's mission critical work.
Yeah. Yep.
All right, more questions. So Ragi's asking, how do you actually decide which model handles which part of the job? And what do you trust a model to do completely autonomously, and what always needs a human? So let's address this first part of the question.
Yeah, so like I've mentioned, we're on the Claude Max for all of our human managed sessions. And so that's kind of where we live, is mostly Claude. I do use Codex. If I ever find Claude is spinning in circles or annoying me, I'll go to Codex and I'll say, hey, I'll have Claude. I'll say, give me a summary of where you're at, and I'm going to tell Codex, and we're going to go from there. That's how I do kind of our human managed sessions. Alfred, it is up to we usually do a team of three. The team of three proposes what's there and then proposes an agent for each stage. It says, I recommend Claude is the engineer. I recommend GPT is the QA stage, and I recommend Gemini is the PR stage or the review stage. Yeah, so it's actually self-managing that based on the models we give available to it to choose from.
And what do you trust the model to do completely autonomously, and what always needs a human?
So far, we more and more are pretty much trusting the results we get between Optibot and Alfred for anything that's bug or a general improvement. There's a lot of things that's flagged have been accessibility stuff. It's actually gotten really good at saying, hey, you're missing a label here that would make this more accessibility appropriate, things like that. And it's done some pretty deep, thorough bugs. We've actually caught up on our backlog of things. So we're now looking at letting him into the world of features. And so that's where there's going to be a lot of human review until I get a really good trust in what it's capable of.
So I think that means we need to bring you back on a follow-up episode to see what
We'll see how that goes.
What happens? It's like a 3-6 month check-in to see.
Yeah.
I think, it's amazing. I feel like in the last 3 months, you folks have probably increased your PR velocity by at least 40% from what I could see from the usage metrics. So it's pretty amazing to see how fast and how much you're really pushing the boundaries of what's possible with engineering workflows.
Yeah, for sure. And it's yeah, I mean, it's one of those things, like everything Alfred did got my eyes for a long time. And it's just slowly the confidence is built and the velocity increases.
Yeah, and it's pretty awesome also just to see that if you have the right quality gate in place with Optibot, then you're able to just continue to really push what's possible in terms of PRs and velocity. Grainger, thank you so much. We've run out of time on questions, and I know this has been an action-packed episode in terms of like all of the tidbits that you've shared, and you've been so transparent as well. At least for us, we've really enjoyed having you on the show. So thank you so much, and can't thank you enough for all the wisdom shared today.
Yeah, awesome. Thank you. Thanks for having me.
Awesome. All right. Well, folks, that was Grainger. And now we are actually going to be sharing with you a very quick new feature launch, which is Optibot, our new fixer agent. Take it away, folks.
No secret that standard AI code review tools have a noise problem. They scan your PR, drop 20 comments, and then stop. Every single one of those comments is still on you to read, triage, and go fix manually. With AI-generated code flooding code bases, that backlog is only growing. Today, that changes because we are introducing Optibot as the only agent that can review and fix your code, cutting through the noise almost entirely. When Optibot finds an issue, just ask it to apply the fix right there in GitHub. It acts so you don't have to. You can configure it in your settings, track every applied fix in the dashboard, and watch your review queue actually shrink. Optibot is now the only code agent that reviews and fixes. Live now, link below to try it out.
Oh yeah, that was Mano with our latest fixer agent. So not only can now Optibot review your code, but it can also fix it. And it's a super simple command. You just need to go into GitHub or in your CLI and just ask Optibot to actually fix what it's reviewed. And folks, as a reminder, Optibot is available for free trials. So all you need to do is head on over to getoptimal.ai in order to sign up and start your trial and start using Optibot for all of your code reviews, and also to use it as your quality and judgment layer for your AI-generated code. That's the sign-up link, but you can also head to getoptimal.ai. We have some many wonderful customers that are sharing their stories on the site too. So if you are curious, you can always review some of the case studies too. So we've had an action-packed episode. We've picked winners for our coffee kits as well, but episode 6. And so we'll be announcing episode 6 very shortly. And we're also going to be sharing a link to the Luma event. But for those of you that were not able to join us live today, or if you're interested in sending out the link, these episodes are recorded. And we just posted the sign-up link for episode 6 on the Luma. So feel free to sign up for that. But the other thing also is that all of these episodes are recorded and they are posted on our YouTube channel. So we'll be sharing the link to the episode if you are interested in sharing just a lot of the tips, tricks, and tidbits that were shared in today's episode with your team. And so, it's been an action-packed episode. We've enjoyed so much having you on, but now I think it's time for us to call it to a close. Thank you, everybody, for episode 5. This is our World Cup themed episode, and we're really excited to welcome you for our next one, which is coming up very soon. As a reminder, today we covered how you can ship over 1,000 PRs per month and do it with a really tiny team of humans plus agents. And so thank you so much for joining us for Get Shit Done, episode 5. We will see you really soon for episode 6. Toodles.
Code lines dancing, syntax tight in the limelight. Optibot scanning, got the bugs in its sight. Binary magician, algorithm so clean. Review game strong, AI supreme. Optibot spitting truth in the digital stream. Flipping through the code like a hacker's dream. Lines refined, it's a pristine scene. Future of the craft, you know what I mean. Variables tangled, Opti unties the knot. Logic rewired, every bug gets caught. Precision surgical, scalpel to the stack, turning messy code into a polished track. Zeros and ones, it's the rhythm of the grind. Optibot flows with the powerful mind. Blueprints analyzed, every flaw aligned. It's the future of code, leaving doubt behind. Loops get tightened, functions redefined. Every keystroke checked, nothing misaligned. Debugging beats, Opti drops the bass. In this code jungle, it's setting the pace. Optibot spitting truth in the digital stream. Flipping through the code like a hacker's dream. Lines refined, it's a pristine scene. Future of the craft, you know what I mean. You know what I mean. Code lines dancing, syntax tight in the limelight. Optibot scanning, got the bugs in its sight. Binary magician, algorithm so clean. Review game strong, AI supreme. Optibot spitting truth in the digital stream. Flipping through the code like a hacker's dream. Lines refined, it's a pristine scene. Future of the craft, you know what I mean. Variables tangled, Opti unties the knot. Logic rewired, every bug gets caught. Precision surgical, scalpel to the stack, turning messy code into a polished track. Zeros and ones, it's the rhythm of the grind.